de la bioseguridad y cuarentena para Galápagos. So the agenda for this work is introduction, objective, methodology, the data set, transfer for forecasting, results, and conclusion. So in introduction, according to the Ministry of Environment, 1,076 non-native species is in Galapagos. So in Galapagos have a problem such as the African snake. We propose a solution like the mobile application and the automatically detection and prediction of this infestation. So the objective is create a mobile application that tracks and predicts the new position of the gigant African snake in order to control and eradicate this invasive species. So the methodology, the first step is they create the app to recollect the tracking in the local storage and the field form, and this upload to Firebase and in the cloud to generate a report and use the tracking for training and generate a new position with artificial intelligence. So in this part, with the data set have some issues. The first issues is they don't have enough data about the snakes. So in this case, we use 56,000 of geographic position that tracking activities from the Wikilog. But finally, validation, we can use a data or real data of the gigant African snake. Yeah. So the best result of tracking is with transformer for forecasting, but we need to add more steps like that comings, because these comings to add more precise of positions of these snake. So in forecasting, we need to question what is the next position of the snake for this month. This month. So basically using the attention in this problem, if we need to have attention in this snake, we need to explore each pixel for each pixel to find the caracal. But the transformer architecture focus on the identify which parts to attend and extract the features with high attention to extrapolate to positions. In the next slide, we look how to do this. So this is a simple example how can use this concept for extrapolate to the positions. So in this case, we need to know where Yachai is located. So basically, we can use Google Maps for find the keyword Yachai. So have different results like Paris, France, Universidad Yachai and Dijon, France. So the input is Yachai, which is a query. So in the next step of results is a keys. This keys is so important for compare the input with each Yachai with each case. So in this part, the question is how similarity is the key to query. The first is not similarity. So pass the second. In the second, have a query with Tech, and the second is the Universidad Tech, is to similarity. And the theory is how similarity is the key to query is not similarity. So basically compute the attention mask, how to similarity each case to desired the query. If one find the similarity, the query and case, we generate a value, and mathematically we use this proposal. So we have dates of find these snails, but not only have the dates, have a geographic coordinates. In this proposal, we use a geographic coordinates for generate this encoding. So we extract the encoding of the query key and values and generate different inputs for the neural networks. Each input is each linear transformation for the neural network. So how can calculate the how the similarity between two features, the key and value? Basically, we use a dot product. The dot product is a node that cosine similarity, and this find the two similarity to key and the query values. So basically, when I have the key and value, we can create a attention weighting. So this is a matrix which represents those similarities, and we need to represent of these positions in matrix, and we have the results in 0 and 1 results with a submat function. So basically, we use a matrix of attention by value to result the output, which is generate a new position of this snail. So like the results have with this technique, we have a 120 predicted points where plagues were found in first day of the 16th month with a narrowed 0 out 001 in the geographic system in the X longitude and Y latitude. So the results, we have the month 16 and the 14 month. We have the positions with 1 with best with correct positions and 0 with incorrect coordinates with a 0.001 geographic coordinates correct. So for the results, we use root mean square error, because this error represents of the error in the each coordinate of general error of the each coordinate. Yeah. And also we use to compare a statistical method that proposed for Facebook that Prophet and other neural networks that LSTM and our model, our transformer model, and our transformer model have a base elms, the root mean square error. So, so the conclusion is this research demonstrated to the improved surveillance and efficiency and accuracy, and enabling rapid reporting and proactive responses to potential outbreaks. This integration of mobile text and AI provides actionable insights for target control measure, contributing for preservation of Galápagos and ecological integrity. For the future work, we think is most important to add like that computer vision for when I find the snake, we can have a measure of this snake and look if have eggs on and other other types of non-native species. So this is all. Thank you.
Thank you very much, Jonathan, for your presentation. So we have time for some questions. Any questions? I have some questions. Jonathan, given your results, are you thinking in applying your proposal in other regions to predict other species?
Yeah, we use this model, but change some parameters for predict of the birds migration
Uh-huh.
in the Europa because have some tracking positions and have a good results with this transformer
That's
model.
right. So then your solution is easy to adapt, is flexible, right?
Yeah.
Okay.
Yeah.
Yeah. So thank you very much, Jonathan.